Hello students, welcome back to the online session on basic electronics. Today we'll be learning about light emitting diode, photocoupler and 7805 voltage regulator. So these are the contents we'll be learning in today's session. You can refer page number 46 to 50. Let us see what is light emitting diode. Light emitting diode is commonly called as LED. Okay, it is a two-terminal PN junction semiconductor diode which emits light when activated. So if you check the symbol of LED, it is almost similar to a PN junction diode. It has two terminals, anode and cathode, and this arrow outwards represents it emits light when it is activated. This means that when a suitable current is applied to the terminals, electrons are able to recombine with electron holes within the device, releasing energy in the form of photons. This effect is called electroluminescence. Okay, so this feature is very important in light emitting diode. So, light emitting diode is most commonly called as LED. It is almost like a PN junction, but we can tell that it is a specialized type of diode. Specialized in the sense it is made out of a specific semiconductor and it is having a amount of doping. That is, it is basically just a specialized type of diode as they have similar electrical characteristic of PN junction diode. This means that an LED will pass current in its forward direction but block the flow of current in the reverse direction. Light emitting diodes are made from a very thin layer of fairly or heavily doped semiconductor material, and depending on the semiconductor material used and the amount of doping, when forward bias, an LED will emit a colored light at a particular spectral wavelength. So most of the students might have seen LEDs in your practical or daily approach, right? So it will emit a colored light at a particular spectral wavelength. That is, when the diode is forward biased, electrons from the semiconductor's conduction band recombine with the holes from the valence band, releasing sufficient energy to produce photons which emit a monochromatic light, that is called single color of light. Because of this thin layer, a reasonable number of these photons can leave the junction and radiate away, producing a colored light output. So if you see the working of the LED, the recombination of electron holes, okay, that will illuminate light, okay, that is called electroluminescence. We can say that when operated in a forward bias direction, light emitting diodes are semiconductor diodes that convert electrical energy into light energy. Very important. So when the LED is forward bias, it will convert electrical energy into light energy. So that's why the name light emitting diode. Okay, so in the working, you can see here there's a battery. It is in forward bias, right? So the positive terminal of the battery is connected to the P side, negative terminal is connected to the N side. Okay, because of the recombination of electron and holes, photons are generated and it will be, in the form of light that will be emitted. Okay, so how does a light emitting diode gets its color? So that's the question. Unlike normal signal diodes that is made for power rectification or detection, these are made from, that is PN junction diode is usually made from germanium or silicon semiconductor materials, right? But light emitting diodes are made from exotic semiconductor compounds such as gallium arsenide or gallium phosphide, gallium arsenide phosphide, silicon carbide or gallium indium nitride, all mixed together at different ratios to produce a distinct wavelength of color. Different LED compounds emit light in a specific regions of the visible light spectrum and therefore produce different intensity levels. The exact choice of the semiconductor material used will determine the overall wavelength of the photon light emissions and therefore the resulting color of the light emitted. So like this, the metal contact of P material is made much small to permit the emergence of maximum number of photons so that in an LED the light lumens generated per watt of electric power is high. Intensity of light increases almost linearly with forward current depending on the semiconductor material used. The voltage levels of LEDs are 1.7 volts to 3.3 volts, which is compatible with solid state circuits. The response time is short and light contrast is good. LEDs emit red, green, orange or blue. Okay, LEDs are used in several display applications such as 8-segment display or that is numbers from 0 to 9 or LED TVs, etc. So as I told you, there are, it will emit light like green, red, orange or blue, but it also will emit different ranges color like amber, or it can be white also these days. So thus the actual color of light emitting diode is determined by the wavelength of the light emitted, which in return is determined by the actual semiconductor compound used in forming the PN junction during manufacture. Therefore, the color of the light emitted by an LED is not determined by the coloring of LED's plastic body, although these are slightly colored to both enhance the light output and to indicate its color when it's not being illuminated by a electrical supply. So, light emitting diodes are available in wide range of colors, with most common being red, amber, yellow and green, and are widely used as visual indicators and as moving light displays. Okay, recently blue and white colored LEDs are also available, but these tend to be much expensive than normal standard colors due to production cost of mixing together two or more complementary colors at an exact ratio within the semiconductor compound, and also by injecting nitrogen atoms into the crystal structure during the doping process. Okay, so this is about light emitting diode. So in the exam point of view, if you can draw this diagram, okay, there is a metal contact, then the combination of holes and electron emitting photons, okay, as lights. Okay, so this is exactly about light emitting diode. So you understood that light emitting diode is a special type of PN junction diode which is making use of exotic semiconductor materials, okay, like gallium arsenide, gallium phosphide, having a different mixing ratios will give you different kinds of visible lights. Okay, so it can be red, yellow, any color. So you all have seen LED, so you will have now better understood actually how a LED is working. Okay, and it is not depending on the outer layer of LED being covered with some colors of plastic, no, but actually because of that particular wavelength at that particular spectra that gets emitted in the form of different colors. Okay, that can be red, yellow, orange, amber, etc. Okay, so I hope LED is clear for you. Now let us move on to photocoupler. Photocoupler is a package of an LED and photodiode where the circuits are electrically isolated as shown in the figure. The LED is forward bias and photodiode is reverse bias, and the output is available across R2. So, photocoupler is also called as optocoupler. It can be called as optocoupler, or it can be also called as optoisolator. So what is this photocoupler or optocoupler or optoisolator? It is a device that transfers electrical signal between two electrically isolated circuits through light energy. Optoisolators prevent the high voltages in one part of the circuit from affecting or destroying other part of the system. So if you see, it is a device, it has two diodes. One is a source or emitter of light, usually a light emitting diode. And the other is a photodiode acting as a photosensor. So if you see here, this is the light emitting diode and this is the photodiode, photosensor. It is acting as a photosensor. The LED, what it will do, it will convert electrical energy into light energy, right? So it will convert an electrical input signal into light, and the photodiodes detects the incoming light, and based on the incoming light, either it generates corresponding electrical energy, right? So this is the working principle of opto isolator or photocoupler. So it's very simple and interesting. So the output signal of one circuit can be controlled by varying input signal in another circuit. Where the two circuits, if you see these two circuits, these are electrically isolated. It is not, it is not a network. It is electrically isolated. Okay, a powerful light emitting diode is connected across a variable voltage source. By adjusting the input voltage across the LED, the intensity of the light emitted from the LED can be controlled. The variable source and the LED form the input circuit of the optocoupler or the photocoupler. A photodiode is present in the front of LED so that light from LED directly strikes the junction of the photodiode. The photodiode is in reverse biased condition. The reverse bias circuit of the photodiode forms the output circuit of the system. It is also, ensure that there is no other light falling on the photodiode junction, and the system is protected from any external light except the light coming from the LED. Initially, no voltage is applied to the LED, hence the LED does not glow. In this condition, as no light falls on the photodiode, there will be only dark current. Right? There will be only dark current. So, the output signal of one circuit can be controlled by varying input signal in another circuit where the two circuits are electrically isolated. A powerful light emitting diode is connected across a variable voltage source. By adjusting the input voltage across the LED, the intensity of the light emitted from the LED can be controlled. The variable source and the LED form the input circuit of the photocoupler. The variable source and the LED, it is the input circuit. A photodiode is present in the front of LED so that the light from LED directly strikes the junction of the photodiode. The photodiode is in reverse bias condition. The reverse bias circuit of the photodiode forms the output circuit of the system. So I told you initially, if no voltage is applied to LED, what happens? LED does not glow. So in this condition, there will be only dark current which will be flowing across the photodiode, right? Dark current is a reverse saturation current of the reverse bias photodiode when it is entirely dark. If the voltage across the LED is increased, the LED starts glowing, and at the same time intensity of the light increases with increasing input voltage across the LED. With increasing light intensity, the reverse current in the photodiode increases. Since the reverse current in a photodiode is linearly proportional to the intensity of the light falling on the photodiode junction, also if the intensity of the light in the input is decreased, the output photodiode current will also decrease. So it's very linear. Okay, so directly proportional. If the intensity of the light is increased, then the output, that is the photo current, also increases. Same way, when the intensity of the light falling on the photodiode junction is decreased, photodiode current will also decrease. So if you see, the main advantage of photocoupler or opto-isolator or optocoupler is that there is isolation between two circuits. So these two circuits are electrically isolated. They are not connected, they are isolated, but still we are getting the output as we want the specified output. We want increase or decrease. It will just depend on how you are going to change or vary the input signal, and depending on that, LED will give the output as light and depending on the intensity of the LED light, we will get the output across the photodiode. So I hope photocoupler is clear for you. You have two circuits here, one input circuit and one output circuit. That's why the name photocoupler. There is a coupling. Okay, so in the input circuit we have a variable source input as well as LED, and the output circuit you have a photodiode and the load, that is output taken from the load. Okay, output is taken from R2. Okay, from here output is taken, right? So now depending on this you can get what the desired output. Okay, I hope this is clear for you. Now let us study about voltage regulator. So you all know that in case of rectifiers only we have studied the terminology regulator, and Zener diode we also studied what does a Zener diode as a voltage regulator do. So regulation, getting a regulated output is very important for any circuit to work. So let us see about 7/8-axis series voltage regulator. So it is a family of self-contained fixed linear voltage regulator integrated circuits. The 7/8-axis family is commonly used in electronic circuits requiring a regulated power supply due to their ease of use and low cost. So this 7/8-axis family, this electronic circuits are usually almost everywhere, because the two main advantages is very easy to use and it is very cheap. It is available in market at a very low cost. For ICs within the 7/8-axis family, the axis is replaced with two digits. That is, axis can be 05, 06, 08, 10, 12, 15, 18 or 24, indicating the output voltage. So if you want to get the output voltage, that is regulated output voltage, say 18, then you have to use which IC? That is 7818. If you want 5 volt output, then you have to use 7805. So it is very clear, 78 represent the series, the family series, and 05, that last two digit, will represent the output voltage. Okay, so different kinds of output voltage will be there. It can varying from 05 to 24 volts. So the LM78axis is a positive voltage regulator. They produce a voltage that is positive related to the common ground. LM788axis ICs have three terminals and support an input voltage anywhere from around 2.5 volts to 35 to 40 volts depending on the model, and typically provide 1 or 1.5 amperes of current. So it is a how many terminal device? It is a 3 terminal device, and its input voltage will range from 2.5 to 40 with a current that can provide from 1 to 1.5 amperes. Okay, now let us see about 7805 fixed IC voltage regulator. So 7805, exactly we know that it will provide a regulated output of 5 volts. Okay, so it is actually a member of 7/8-axis series of voltage regulator ICs, and it is a fixed linear voltage regulator. As we know, it has 3 pins, okay, 3 control pins, 1 V in, 2 as the V out, and 3 as the ground. Pin 1 is the input, pin 2 is output, and pin 3 is connected to ground. LM7805 has an output voltage of plus 5 volts and a maximum load current over 1 ampere. Pin 1 is the input pin. This pin is used to apply the input voltage. Input voltage can be in the range of 7 volts to 35 volts. Pin 2 is the ground. This pin is connected to ground. Pin 3 is, this pin is used to take the regulated output, that it will be 5 volts, right? In 7805 the regulated output will be 5 volts. The output of the rectifier is an unregulated DC voltage. Therefore, two capacitors are required to obtain a regulated DC voltage. So this is exactly how 7805 looks like. So you have two capacitors to get a regulated DC output voltage of 5 volts. Okay, so one capacitor in the input side and one capacitor at the output side, and from that we will get the output, which is exactly a regulated output of 5 volts. I hope these three concepts are very clear for you: light emitting diode, photocoupler or optocoupler, and voltage regulator. So voltage regulator in particular, you will be studying about 7805 voltage regulator, which will provide a regulator output voltage of plus 5 volts. Okay, so in the exam point of view, if you can expect any of the questions from all these four concepts, the photodiode which I've already done in the previous session, or it can be from light emitting diode, or it can be from photocoupler, or it can be from uh, that is voltage regulator. I hope these three concepts are clear for you. Thank you.